remember that if there was a 1, wouldn't it be there? That's what I always say. If there was a 1, it'd be there. So there's zeros here, aren't there? So H is 0, K is A. What's A?
9.
No.
3.
A is the square root of 9, which is 3. B is what? That comes from the square root of 25 right here, which is 5. Now, a bunch of you would probably jump up and say 4 for C, but it can't be.
Oh, I just did.
In a hyperbola, which piece is the longest? This is not a Pythagorean triple. It's in the wrong order. But to find C, we know that what? A squared plus, so we know A is 9, A squared is 9, B squared is 25, gives us C squared, this is 34. Take the square root, and we get C is about 5.8. I'm going to guess 5.8 this time. Take the square root of 34. Almost 6, right? All right. Do we have everything we need to be able to graph this? Well, we'll have to draw all that in. We'll have to come up with those as we go, won't we? So let's actually do this. You know what? Does everybody have this written down? Because I think what I would like to do is switch over to the other board and actually use the graph paper. Because I have this all written down. Is everybody good with that? All right. You got this? Okay. So I'm going to switch to this. And this. And this. There we go. We have lovely, lovely stuff there. All right. So we said that H, oops. We said that H was 0, K was 0, A was 3, B was 5, and C was approximately 5.8, didn't we? And we said it was vertical. Okay, so let's draw, and actually draw this guy right. So where is the center for this? We might as well list things as we go. Where is the center to this hyperbola?
0, 0.
It is at 0, 0. So we have the center right here at C. All right. That's what I said put in first. Then I said put in the vertices next, didn't I? How far is it from the center to the vertices and which way? Up and down or left and right?
Up and down.
Yeah, because it's vertical. So how far from the center to the vertex is what?
C.
And that's the center to the foci.
It's
It's the same as for an ellipse, guys. From the center to the vertices is A, isn't it? So that's 3 spaces. So 1, 2, 3 spaces up. And 1, 2, 3 spaces down. So this is vertex 1 and this is vertex 2. Now we have to put in our asymptotes, don't we? Our asymptotes, it is rise over run, right? So when you forget this, you're going to forget. You're going to be going, oh my gosh, is it A over B or B over A? I can't remember. This is going to tell you, isn't it? How far is, which one is this? This is A, isn't it? So it is going to be A is your rise this time, correct? So it is going to be rise over, so it will be 3 over, your slope is going to be plus or minus 3 over 5. So we're going to go up 3 and over 5 this way. And we are going to go from here, we are going to go down 3 and back 5. So there is my first asymptote being laid in. And now we need the other one. So if this one has a positive slope, the other one must have a. So down 3 and over 5. And up 3 and back 5. So here we go with this guy. There are my asymptotes. We can now draw in the actual parabola, can't we? So let's draw the parabola in, and we'll draw it in red, so we see it. This thing does not dip down and go back up. This thing never goes further in than this vertex. So we are going to start running it this way and towards this one's very flat and shallow, isn't it? Towards the asymptotes. There is our hyperbola. The only thing we have left to do is put in the foci. The foci are going to be oriented the same direction as the hyperbola. And the hyperbola is oriented which way? Vertically. So shouldn't the foci be somewhere here and here? How far from the center to the foci? Yep. C, which is, so we need to go 1, 2, 3, 4, 5.8 here. Here is foci 1. And 1, 2, 3, 4, 5.8 this way. And here is foci 2. And that is graphed. Now if we needed to, we could label all the parts, couldn't we? Where was the center was here, where are the vertices at? 0 and 0 plus or minus 3, which put them at 0, 3 and at 0, negative 3. And then the foci would have been 0 and 0 plus or minus 5.8, right? H, K plus or minus C. So these would be at 0, 5.8 and at 0, negative 5.8. And then finally for the asymptotes, the asymptotes would be y minus k plus or minus, in this case it would be a over b. So 3 over 5 times x minus 0, which really just makes this y equals plus or minus 3/5 x, doesn't it? So that's all the information that goes with that graph. Again, you don't have to know all those individual formulas. You don't have to memorize it all, do you? You got to know the master formula to be able to pull out your h, k, a, and b. You need to know the Pythagorean relationship for it. That's 2. And then all you need to know is the distances, that this is A, that this is C, and then you need to know that box, don't you, in this case, which is distance from here to here would be B. Okay? Those are the pieces you need to be able to graph. All right, so are we good to go on this? Okay.
What do you need to find the foci? What's the point of it?
Foci are kind of, this works kind of the same way. It's a focal point. Foci means focal point, which means if you've got, just like when you have a parabola, that shape reflects things to the focus. Same thing goes with a hyperbola. You can have a hyperbolic dish, and it will focus things to the center as well, to that focus as well. Okay? When we look on Monday at real-world applications, we're going to look at real-world hyperbolic shapes and that relationship to the focus. Okay? But it's a specific point. Remember, the foci tell you that are part of the definition, aren't they? We don't say those places are equidistant from the vertices. We said they're equidistant from the foci. So if you don't put those in, you don't know what the actual, you're not putting in the thing that actually makes it a hyperbola. 2 things make it a hyperbola. The asymptotes and the foci. Okay? All right. Are we good? Is everybody caught up? Not wake up. Good grief. Is it just because it's warm in here? All right. Okay, so let's pick and let's look at let's do an example 3 and then we'll jump to writing the equations. We've got lots of time, so we should be good. Here's our example number 3. It's missing a little chunk, it was up at the top. So we'll put that in. That's what yours looks like, right? So why did I pick this example? What are we going to have to do? Complete the square twice. This one's got a little trickiness in it though. We've got our x squared. The positive one always has to go first, guys. Notice this one's got a minus in front of it. Do you realize that one of them is always going to have a minus in front of it? It has to, otherwise how do we get that minus sign in between? If it was all pluses, it would be an ellipse. So this goes with the plus 100x. Then we have minus 16y squared. That goes with the plus 96y. And that's going to be equal to 444 over here, isn't it? So what's the first thing I need to do? Yep. Factor out, factor out. So we're going to factor out 25 out of this guy, and we're left with x squared plus 4x. And what do I factor out of this? Negative 16.
25 plus 25.
Which makes this y squared and what? Minus 6y, good. That right there will mess you up. You will miss the whole problem if you don't get that sign right. When you pull out a negative, you've got to have that sign correct. It's a simple algebra mistake that happens and it messes you the whole thing up. Because then you complete the square wrong. The sign is wrong for completing the square, which makes your vertex, the center wrong, which makes all your other pieces wrong, doesn't it? Yeah. That'd be a whole lot of work for one little sign error. So now, complete the square on this guy. Half of 4. Square it.
4.
Now we have to look at this, don't we? 25 times 4 is what? Positive 100, which means we have to add 100. Complete the square here. We have what? So we have 9 here. But now look. Negative 16 times 9 is negative 144. So we have to subtract 144. We're no longer adding, we are adding and subtracting, whatever that second one is. Will be subtracted from the other side. Okay? Because of this minus sign right here. So be careful, don't make any mistakes. So this is now 25, and this is the perfect square of what? Yep. X plus 2 squared minus 16 times, this is the perfect square of 1 minus 3 squared equals 400. What's my last step here? Divide everything by what? Divide by 400. Divide by 400. Divide by 400. 25 goes into 400 how many times? Okay. So this is over 16. And then y minus 3 is over what?
25.
Thank you. I cannot tell you how many times today I've had to point out, if you take 25 into 400, you get 16. Don't you get 6? You take 16 and go up to 400, shouldn't you get? Did I hear you how many times somebody's gone? Equals 1. You just don't think about it. So now from this we need H, K, A, and B. So what is H?
-2.
K is? A. Yep, it's going to be the square root of 16, which is 4. This is A squared, and what is B? Square root of 25, which is 5. Still not a Pythagorean triple. So to find C, we need to do A squared plus B squared equals C squared this time. So we have 16 plus 25 is C squared. So C is the square root of, which is approximately what?
6.4.
All right. Now, we need to graph it, don't we? Okay. So let's graph it. I'm going to go to the other board, okay? Give everybody a chance to catch up, and we'll go to the other board and graph it. Is this stuff starting to feel a little bit less scary? A little bit, a little bit. I hope. Okay, then I'm kind of there.
What class is that?
Geometry, I'm sure, or finance, one of the two. Is it finance? Yeah. They're probably playing Quizlet or something. No, you won't. Are we good? Can I switch over now? All right. Here we go. We had an H that was -2, a K that was 3, A is 4, B was 5, and C was 6.4. Oh, and which way was it oriented?
Horizontal.
Yep, it was horizontal because it was, which was first? X. So let's graph this thing fairly quickly. I want to move on. All right, so the center is at what? From -2, 3. -2 up 3, here's my center. Okay, now I need to do my vertices. This thing is oriented horizontally, so which one's going to be affected, the H or the K? We're moving side to side, aren't we? If it opens horizontally, shouldn't they be this way?
Yeah.
That would affect the X, which is, so -2 plus or minus how much?
4.
And then 3. So we are at -2 minus 4, which is -6, 3. And we're at -2 plus 4, which is 2, 3. So we're -6, 3. 2, 4, 6, 3. Here is vertex 1. And 2, 3. Vertex 2. All right?
It doesn't matter which vertex is which, does it?
No. You can call it the other way. Doesn't matter. There's no specificity there. All right. So let's find the asymptotes. Let's actually find the equation for the asymptotes. So it is going to be y minus k plus or minus something and x plus 2. Would you agree? This is the something we need. So this is where you always screw up. You're like, oh my gosh, is it A over B or B over A? All you have to do is look and ask yourself, rise over run. This time your A is your what? It's your run, isn't it? So the slope has to be B over, so 5 over 4. So there are my two equations. There's 2 in 1 there, isn't there? So let's put those in. So we have to go up 5 and over 4, down 5 and over 4. And there's one of them. Ooh, wow, that's bad. And we need to go up 5 and back 4. And down 5 and forward 4. It's harder to see across this big space with the shadows than you think. So hard as that, it was invisible. There we go. Okay. So can we draw in our hyperbola now? Yep, we can. Hyperbola is going to go from here forward. From here forward. Here forward. Here forward. There we go. And all we have left to put in is the what? The foci, yes. foci, doesn't matter. All right, so foci. Foci are also going to be in the horizontal, aren't they? So they are going to be h plus or minus what this time? Yes, somebody said it, 6.4. So -2 plus 6, or -2 minus 6.4 means one of them is at -8, -6 point, or, I'm sorry, hang on. Your teacher is having a stroke moment. And 3. They actually need 2 coordinates, don't they? So -8.43. And what's the other one going to be? What? Thank you. 4.43. All right. So -8.43. 2, 4, 6, 8.43. So it puts it right about here. There's like 1. And 4. So 4.43 puts the other one here. There's like 3. Okay. Are we good? Yes? No? Sort of? Somewhere in between? Are we firmly a yes? Are we this way or are we this way on that? Kind of a little bit above? All right. Guys, the only way to get good at this is to practice it, which means doing those homework problems. I'm sorry. It is one of those things where you're not going to get all the formulas in your head unless you do the homework. Because remember, I'm not giving you the I don't care how much you beg, I'm not giving you the formulas on that test. You have to know it. If you know the stuff, it's going to be an easy test. If you don't have these relationships down, you're just going to sit there the entire time and beat your head on the desk. Or cry. There's no crying in math. No crying. Already had somebody say, I like crying. I cried last night over this homework. I was like, dude.
I like crying.
Yeah, it was God. All right, here we go. We've got about 11 minutes left. We've got plenty of time. So writing the equation. Look at what this says. It says the same stuff it said when we did ellipses. It says do what first? Sketch to figure out if its orientation, right? Yeah. Okay. And then once you have that sketch and you know what the orientation is, you can find your H, your K, your A, and your B. That's all you need, don't you? And if you know the orientation, you know what the general form is, and you plug in your H, K, A, and B, and you're good. So let's do this. Got to get at least one done. So we are going to sketch this. So here goes. So here's my sketch. They give us the vertices. How are the vertices going to help us know what the orientation is? Yeah, they're either going to be this way or they're going to be, as Eli put it, yeah, they'll be in line with which direction it's oriented, won't it? So, -3, -6 puts one of them here. And the other one is at -3, +2, which puts it right here. So which way is this guy oriented? Vertically. So it is vertical. which means that it is the equation what? Over
A squared minus X.
equals, okay. So, this is going to give me 3 of those 4 things. Because if I connect these up from here to here, what is that distance from vertex to vertex?
8.
Okay, it's 8. And it's also what? 2a. So this is 8, and that is equal to 2a. So a is what? 4. So a is 4. Now, that's one thing. I said it gave me 3 of the 4. What other thing can I find from this? What lies between the vertices? Oh, the center. How about that? The center does. So the center is going to be exactly how many units down from this point? Yeah, 4. So 2, 4 puts it right here, doesn't it? Well, there's my center. So what is my center point at?
-3, -2.
-3, -2, and that gives me what? Yep, h and k. So h is -3 and k is -2. Now all I need is b. The foci. Will the foci give me b?
No.
But what will the foci give me?
C.
C. So I'm going to go ahead and graph the foci here. At least one of them. I don't have to graph both. It is at -3, +3. So my foci is right here. So now all I need to know is the distance from that foci to the center. How far is it from 3 to -2? So this is 5 units, which is what? This is C, isn't it? Well, I don't need C, I need B. But what do I know? Yep, a squared plus b squared equals, and this time, a is 16, b squared, and then this is, so this one is 9, so b is what? Oh, this was 3, 4, 5. Find them. So do we have enough to plug in?
Yes.
So that's what we did. This guy becomes y what? Plus 3 squared over,
Wait, 16.
yep, a squared, so that's 16.
But K is -2.
It should be 1 plus
Oh,
2.
yeah, duh. Thank you for catching that. That plus 2 minus what?
X plus 3 squared over 9.
X plus 3 squared over
9.
9. Okay, because b was 3, so this is 9 equals 1. Yeah. So we're done. All right. It's 3:25. I think you're done for the day. You're probably fairly brain fried. Does anybody have any final questions?
Do you have the speeches from Alpha Theta yet?
Yeah.
Ah, nice.
What do we do?
Just show up and you sit there. Be nice and be supportive.
Is Duffey the rest of the examples?
Yeah, absolutely.
She just sit there.